Hello, I am Mamleen. Welcome to my general mathematics class.
Good day. Our topic for today is about rational functions. Content standards will be the learner demonstrates understanding of key concepts of rational functions. Performance standards, the learner is able to accurately formulate and solve real-life problems involving rational functions. For this lesson, the most essential learning competency is the learner represents real-life situations using rational functions. For lesson 1, we have understanding the rational functions. To start with the lesson, let's have the definition of rational function. A rational function r of x, is a function of the form r of x or function r of x is equal to the function p of x divided by the function of q of x, where p of x or function p of x and function q of x are polynomial functions, and the function q of x should not be equal to 0. And the domain of the function r of x is a set of real numbers such that q of x is not a 0. Now let's have some examples of rational functions. We have the function r of x is equal to x cubed minus 1 divided by x plus 1, where x is not equal to negative 1. Another one is the function r of x is equal to 1 divided by x, where x should not be equal to 0. Now we can see that both numerator and denominator are polynomial functions. Denominator has a restriction because it should not be equal to 0. The numerator 1 of this example is a polynomial function with a degree of 0. The denominator is a polynomial function and it must not be equal to 0. Next are examples of real-world relationships using rational functions. The local government unit allotted a budget of 100,000 pesos for the feeding program in the daycare center. The amount will be divided equally to all the pupils in the daycare center. Write an equation showing the relationship of the allotted amount per pupil represented by the function f of x versus the total number of children represented by x. Let's show the relationship in a tabular form. So we have the first row with number of children represented by the variable x with values 10, 20, 50, 100, and 200. Now let's have the allotted amount per child if there are 10 children. Okay, we have 10,000 per child for 10 children. For 20 children, we have 5,000 per child. For 50 children, we have 2,000 per child. Now for 100 children, we have 1,000 per child. And lastly, for 200 children, we have 500 per child. Now based on the results from the table, we can come up with the function that will represent the problem. So we have the function f of x is equal to the allotted budget, which is 100,000 pesos, divided by x, or the number of children. Our next example is based on our previous example. Now there is a benefactor who wants to supplement the budget allotted for each child by donating additional 650 pesos per child. If the function h of x represents the new amount allotted per child, construct a function representing the relationship. Let's first represent the relationship in a tabular form. So we have, similar from our previous example, the first row will be the number of children which is represented by the variable x with values 10, 20, 50, 100, and 200. Now if there are 10 children, the allocated amount per child will be 10,000 pesos plus 650 pesos. That is a total of 10,600 pesos per child. Now for 20 children, the allocated amount will be 5,000 plus 650 pesos per child. That is total of 5,650 pesos. Now for 50 children, the allocated amount per child is 2,000 pesos plus 650 pesos. That is a total of 2,650 pesos per child. Now for 100 children, we have 1,000 pesos plus 650, total of 1,650 pesos per child. Now for the number of children, which is 200, the allocated amount per child is 500 plus 650, a total of 1,150 per child. Now our representation will be in the form of function, will be the function h of x is equal to 100,000 pesos divided by x plus 650. Now let's go to our next problem. A car is to travel a distance of 70 kilometers. Express the velocity as a function of travel time t in hours. Let's have the representation of the relationship in tabular. Now the first row is time in hours with values 1, 2, 3, 5, and 10, and velocity in kilometer per hour. Now to recall, the formula for velocity is distance over time, or velocity is equal to distance over time. So dito sa ating problem, we have the distance of 70 kilometers. So if time is 1 hour, what will be the velocity? Okay, it will be 70 kilometers per hour. Now if the time is 2 hours, we have 35 kilometers per hour. If the time is 3 hours, we have 23.33 kilometers per hour. If the time is 5 hours, we have 14 kilometers per hour. And lastly, if the time is 10 hours, we have velocity is 7 kilometers per hour. Now, as representation in function, the formula for the velocity, which is expressed with the function v with respect to t, is equal to 70 over t. Now let's try this example. During the first quarter of the school year, the officers-elect of the Supreme Student Government decided to divide their budget evenly to the different committees. If their budget is 35,000 pesos, construct a function m which would give the amount of money each of the n number of committees would receive. Now, the relationship can be represented in tabular form or in table. Now, we have the first row for the number of committees and the second row will be the amount allocated for each committee. For the number of committees, the values are 2, 4, 6, and 8. Now, if there are 2 committees, the amount allocated for each committee is 17,500 pesos. Now, if there are 4 committees, the amount allocated for each committee is 8,750. If there are 6 committees, each committee will receive 5,833 pesos and 33 cents. Now, if there are 8 committees, the amount allocated for each committee is 4,375 pesos. Now, as representation in function, we have a rational function m with respect to n is equal to 35,000 divided by n. Okay, let's do some practice exercises. First exercise is about pastry corner. Manuel has 10 cups of flour to be used in baking cakes. He wanted to split it evenly among the containers that he will use so that he can adjust the measurements of other ingredients. Construct a function c which would give the number of cups of flour each of the number of containers n will have. So the problem is about or is finding how many numbers of containers will be used with the 10 cups of flour. If we're going to analyze further, we're going to have the function or rational function represented by the function c with respect to n is equal to 10 over n. Next example is the medicine dosage. Let the function c with respect to t be equal to 3 times t divided by t plus 6 be the function that describes the concentration of a certain medication in the bloodstream over time t. If 4 hours have passed after the medicine was intake, how concentrated is it in the blood? Now we have here the value of t, which is 4. Therefore, substituting the value of 4 to t, to variable t, we have c with value of t is equal to 3 times t, that is 3 times 4, divided by t plus 6, that will be 4 plus 6, is equal to 12 divided by 10. Or simplified, we have 1.2. Therefore, the concentrated of the medication is 1.2. Now, next example is how long. The problem is the distance between the school and your home is 5 kilometers. Express velocity v as a function of travel time t in hours. Now, similar with our previous example, we are going to express the function velocity v with respect to the travel time in hours. To recall, we have the formula for velocity, which is distance over time. And as we can see, the distance is equivalent to 5 kilometers. Therefore, our problem can be represented by the rational function function v with respect to t is equal to 5 over t. Now that's all for today. God bless. Thank you.